we're gonna see today chapter 3, section 3.2, Introduction to Functions. The first objective is to define relation, domain, and range. First thing, relation is the set of ordered pairs. Domain is the set of x coordinates, and range is the set of y coordinates. And let's see some examples here. Determine the domain and range of the relation. Well, if we have the relation 4, 9, -4 and 9, 2 and 3, 10, -5. This is the relation. The domain is going to be the set of x, of the x coordinates, every x coordinates. So the domain is 4, -4, 2, and 10. This set of numbers. And the range is the set of y coordinates. So y, 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 y. And the range here then is going to be 9. I don't need to repeat 9, 3, and -5. Okay? It's as simple as that. And now you have a different example here where x, or the input, are names of animals like polar bear, cow, chimpanzee, giraffe, gorilla, kangaroo, red fox, and this, the input or the x, is the domain, and the output of the y, lifespan, 20, 15, 10, and 7. So everything that's output or y is going to be range. And the answer for this example is this. The domain are the animals, the set of animals, and the range is the set of lifespan. Now objective 2, identifying functions. Some relations are also functions, and a function is a relation in which each first component in ordered pairs corresponds to exactly one second component. And the example will show us what does it mean. Is the relation 4, let me write it down here, 4, 9, -4, 9, 2, 3, 10, -5. Is this relation a function? And how do we check it out? Is a function. You see here, 4, for x equals 4, you're going to have y equals 9. And there's no other set that have x equals 4 here. For x equals -4, you're gonna have y equals 9. No other -4 as x. For x equals 2, y equals 3. No other x is equals 2 on this relation. And for x equals 10, y equals -5. That means for each x, only one y. And okay, yes, this is a function. And let's now see examples in the shape of a graphic. Determine whether each relation is a function or not. Well, basically what you're gonna see, let's do the slideshow. Current slide. Okay. Oh, I'm in the way. So see this first graphic here, letter A. You're going to have x. For x equals 3, you have y equals -3 and y equals 2. That means for one x, you have two different y's. So this is not a function. And this other relationship here, this other graphic here, for each x, for instance here, x equals -2, x equals 0, x equals 1, x equals 3, you're going to have only one point, only one y. So yes, this is a function. Example, is this relation a function? And the relation is y equals x squared minus 2x. How do we know if it is a function or not? Basically, if you have, for instance, x equals 0, you plug in 0 here, you're going to have y equals 0 minus 2 times 0, 0. Only one y. For x equals 1, y equals 1 squared is 1 minus 2 times 1 equals -1. That means only one y. Since each element of the domain would produce only one element of the range, it is a function. Let's see another example. Now we have another function here. Is this relation a function? And now we have another function which is x squared minus y squared equals 9. Is this a function? First, let's change this form of the equation and make it as a y, to have just y in the left hand side of the equation, right? So let's subtract -x squared, -x squared from both sides. -y squared equals 9 minus x squared. Let's multiply or divide by -1. That means y squared equals x squared minus 9. And the last thing that we can do here, that we're going to do here, is to square root both sides. But when you square root both sides, you're going to have this. Y equals plus or minus square root of x squared minus 9. And we're going to, actually, we are going to see this later. But in this situation here, for each x, you're going to have two different y's. One is a positive result of this, and the other one is a negative result of this. Okay? Since each element of the domain would correspond with two different values of the range, the relation is not a function. Objective 3, using the vertical line test. This means the vertical line test, it means that if you have actually no way of drawing vertical line that will intersect the graph more than once, then the graph is a function. And let's show the examples so we can see. check this one. The red line is the representation, and we are asking if this is a graph of a function or not. Well, we can try to draw vertical lines, and you're gonna realize that there are no vertical line that you can draw here that will intersect this graph, this in red, in 2 points, right? Let's see, this one point, 1 point, 1 point, just 1 point. So this is the graph of a function. The next one. This is another graph. See, this is a linear equation. Use the vertical line to determine where the graph is on the right is the graph of a function. And now we can see here, we can check these vertical lines here. And you see that all the vertical lines will intersect this graph in how many points? Just 1 point, right? So, yes, this is a function. What about this graph here? This is an oval. This red graph. Is this a function or not? Well, we have vertical lines here that intersect this graph in no point at all. But we can draw vertical lines that intersect the graph in 2 points. More than 1 point, 2 points. That means, no, this is not a function. So, a hint here. Since the graph of a linear equation is always a line, all linear equations are functions, but except those whose graph is a vertical line. And now we're going to objective 4, finding the domain and range of a function. And let's use this thing here. We want to find the domain and range. Domain, we've seen that domain is the X set. So domain is the X set, right? And range is the Y set. So if we want to find the domain, let's have a look at this function here. What's the domain of this function? And note that the function doesn't have this line here doesn't have arrows here, no arrows. No, let's get this. Let's remove this. What does it mean if it doesn't have arrows? Means it's just a segment of a line that starts on this point and ends on that point. If it doesn't have arrow, okay. So what's the x set of this function here? The x is going to start here, and let's say is -3 here, right? 1, 2, 3, -3, and is going to end there. 1, 2, 3, 4. That means the domain starts on -3 and ends on 4. And what about the range? Range is y. So let's check y. The range is going to start here. And this is -1, -2, -3, -4. Okay. And we'll end here on 1, 2. So the range is -4, 2. That's how you find, given a graph, you find the domain and the range. So let's work another example. now we have another graphic, and note that we have here, what we have here, the arrows. Notice that we have arrows now, and that means this graphic actually goes all the way to infinity. On this part of the graphic here, it goes to negative infinity. On this is going negative infinity on x, right? And positive infinity on x, and goes all the way up to positive infinity on y. If you reflect the graphic on the y, on the x axis, you're gonna find reflections all the way to negative infinity. You're gonna reflect the graphic here on x all the way to positive infinity. And the same thing if you reflect the graphic here on y, is going to go all the way to positive infinity. And now, since we've realized this, what's the range? The domain first. Domain is going from negative infinity, and use parentheses here, negative infinity, or every time you represent negative infinity in this kind of representation, the interval notation, you use parentheses, to positive infinity, parentheses. And the range, the lower point of the graphic is this one, right? Which is -1, -2. And it goes all the way to positive infinity. And here parentheses. So domain from negative infinity to positive infinity, and range from -2, included -2. This bracket here means that -2 is included, all the way to positive infinity. Okay, great. Now we can go to the next objective, number 5, use function notation. To denote that y is a function of x, we can write something like that. Y is equal f parenthesis x, that we're gonna read like y equals f of x. That means function of x. This notation means that y is a function of x. For this reason, y is called the dependent variable and x is the independent variable. Important thing to note here is that does not make confusion, and this doesn't mean that y equals f times x, okay? No f times x. Y is a function of x, or f of x, not f times x. Some examples. Find the function if fx equals negative 4x minus 1. So the first one, fx equals 4x minus 1. Find f2. That means the function of x equals 2. You're gonna plug in x equals 2 on the equation, on the function, on this expression here, and then you're gonna have 4 times 2 minus 1, which is 4 times 2, 8, minus 1, 7. So f function of x equals 2 equals 7. This is as simple as that. Another example, if gx equals x squared minus 2x, find g of x equals -3. Again, you have to plug in x equals -3 on this expression here, which is g of x. So g of x equals -3 equals -3 squared minus 2 times -3. -3 equals -3 squared is 9, right? Minus 2 times -3, negative and negative positive, 6, 15. Okay. More examples. No, this is the same thing. And this is interesting. Let's see on the graphic here. Given the graph of the following function, find each function value by inspecting the graph. So what's the function of x equals 5? And the first thing we need to do here is to find x equals 5. 1, 2, 3, 4, 5. So this is x equals 5. Right here. And when x equals 5, y is going to be 1, 2, 3, 4, 5, 6, 7. 7. So when x equals 5, y equals 7. That means function of x equals 5 equals 7. For function of x equals 4, now 4 is here. Let's go. Now the function of x equals 4 is 1, 2, 3, 3. Function f equals function of x equals -5. 1, 2, 3, 4, 5, -5. Now we intercept the graph here, and y equals -1. -1. And the last one, function of x equals -6. And -6 is here, right? -6 here. Let's intercept the graph. Go all the way to this point where y equals -1, 2, 3, 4, 5, -6. -6. And that's how you find the function by inspecting the value of the function by inspecting the graph. Okay, now objective E. Graph a linear function. And we know that the linear function is represented by a linear equation, right? mx plus b, this is a linear equation. And a linear function is going to be fx equals mx plus b. So a linear function is represented by a linear expression or equation. In this situation here, an equation. Example, graph the function fx equals 3x minus 2. And to graph this function, basically we need to find values of the function given some values of x. Let's say if x equals 0, fx equals 3 times 0 minus 2, negative 2, right? If x equals, let's say 2, fx equals 3 times 2 minus 2, 4, right? 3 times 2, 6, minus 2, 4. And if x equals, let's say 4, x equals 3 times 4 minus 2. 3 times 4, 12, minus 2, 10. Now we come here to the graphic and find x equals 0, fx equals negative 2. So let's graph the function. For x equals 0, fx or y equals negative 2. X equals 0, y equals negative 2. 1, 2, negative 2. For x equals 2, fx equals 4. So here x equals 2, fx is 4. And x equals 4, fx equals 10, or y equals 10. 5, 6, 7, 8, 9, 10. Let's get the ruler and align the ruler with these 3 points. And then we can graph the function.